Einstein's Relativity by Katherine Dorch. Crazy hair, space, time, and E=mc² all come to mind when the name Einstein is mentioned. As the brain behind the famous theory of relativity, Albert Einstein was a major contributor to the understanding of the inner workings of our world. Without him, scientific advancements in the knowledge of elementary particles would not have been made, not to mention the lack of nuclear understanding we would have. In addition to these advancements, his theory of relativity did not only help the scientific community, but aided in political, social affairs as well. Einstein was born on March 14, 1879 in Ulm, Germany. Even at an early age, Einstein was fascinated by science. On one occasion, it is told that the young Einstein was given a magnetic compass needle and he was in awe of the invisible mechanisms that made the instrument work. True to the stories, Einstein struggled in school, but not in his beloved subjects of math and science, where he excelled. It was his lack of interest in other subjects that led him to cutting classes and cramming for exams. After moving from Germany to Italy to Switzerland, young Einstein finally graduated high school in 1896. Although only 17 at the time, he decided to further pursue his education of mathematics and physics at a 4-year teaching diploma program at the institution of ETH Zurich. After graduating from the Zurich Polytech School, Einstein spent 2 long years in search of a teaching job, but to no avail. It was in Switzerland that Einstein finally found work as a patent clerk at the Federal Office of Intellectual Property, where he evaluated patents for electromagnetic devices. It was from the work he did as a patent clerk that helped influence his thoughts on the nature of light as well as the connection between time and space. In 1905, in what became known as Einstein's Annus Mirabilis, or miracle year, because it was during that time that Einstein had 4 groundbreaking papers on the Brownian theory, photoelectric effect, special relativity, and equivalence of mass and energy published. For one of the first times in his life, Einstein finally had the attention of the academic community. It was in a few of these 4 papers that Einstein laid the groundwork for his theory of relativity, that is, E=mc². In his paper titled On the Electrodynamics of Moving Bodies, Einstein described major changes to the process close to the speed of light, what would later refer to as special relativity. From the paper, Does the Inertia of a Body Depend Upon Its Energy Content? He stated the equivalence of mass and energy in the basis of nuclear energy. At the time, this theory of Einstein shocked the scientific world because it went against all previous thought. Other scientists of the age had been working on ideas that energy had discrete properties, but Einstein's hypothesis went way beyond this. As part of his theory of relativity, he concluded that light could act as an independent particle with similar properties of that of a gas. This concept completely contradicted previous scientific thought that light consisted of smooth, oscillating electromagnetic waves. In 1916, Einstein furthered his fame by proposing the special relativity theory. According to the abstract of his work, special relativity is the idea that the universe has 4 different dimensions. The first 3 of these dimensions are what makes up what is space, while the 4th dimension is what he referred to as space-time, a dimension where time and space are connected. Special relativity is a lot like the general theory of relativity in that 2 people observing the same event at the same time would experience it at different times depending on their distance. The main example of this is light, because light travels at the same constant speed. So the observer that is closer will experience seeing the light before someone at a further distance. This shows how time is dependent upon space. Another aspect of Einstein's theory of relativity is that he proved that space curves due to matter. Black holes are a perfect example of this phenomenon that would otherwise be impossible to observe. In the extreme case of black holes, a huge amount of matter is squeezed into an infinitely small volume, causing the space around the hole to curve inward. Thanks to Einstein's theories, we now know a little more about how our universe works. Not only did Albert Einstein's theory of relativity change the scientific community, it also had major impacts on the world events and our modern-day national security. As the Nazi regime began gaining power in Europe, Einstein left his German roots for the United States in 1933. There he was able to teach as a professor at Princeton due to his now world-renowned fame for his scientific theories and mathematical equations. It was during World War II that Einstein's theories were put to use to gain leverage over the Axis powers. According to the official Albert Einstein archives, it was thanks to his greater knowledge and understanding of physics, along with his strong stance on military preparedness of European democracies against the threat of Nazism, that Einstein was able to help develop the Manhattan Project, otherwise known as the atomic bomb. Einstein's strong advocacy against the Nazi regime was demonstrated by a letter he wrote to President Roosevelt insisting that as president he endorse an American nuclear research program. Once approval to move forward with the project was granted, it was in large part thanks to Einstein's equation equals mc squared that the atomic bomb became reality. It was because of this equation that Einstein and other scientists working on the project were able to understand and harness the powerful energy that resulted from splitting a uranium atom with a neutron beam. By helping create the atomic bomb, Einstein contributed to developing our nation as a superpower. After the United States dropped the bombs on Japan, Einstein realized the immense devastation that such a weapon could potentially create for humanity. In response, he began to use his fame in order to bring change to the world and became a big supporter of international collaboration and war prevention. There is no denying that Albert Einstein was one of the greatest minds of the 20th century. Through his abstract thinking came concrete success in the fields of physics and mathematics, as well as helping to shape the modern world. His theory of relativity changed the world and the scientific community by shedding light on the inner workings of Newtonian physics. His seemingly simple, universally known equation not only changed the scientific community, but the world itself. Without helping to create the atomic bomb and giving the United States that leverage, who knows what the outcome of World War II could have been. In addition, Einstein's work led to the development of lasers and computer chips, both of which have dramatically changed the world we live in today. He paved the way for new and innovative thinking in the field of science, and as he said, science is nothing more than refinement of everyday thinking.